Right now, something you have never met is deciding what you watch tonight. It doesn't know your name. It has never seen your face. It has never read one word about the movies it's about to hand to you. And here's the uncomfortable part. It's usually right. So how does it pull that off? Not the answers they put in the press release, the real one, the math. Because underneath every recommended for you is one of the most beautiful ideas in all of linear algebra. And by the end of this video, you won't just understand it, you will have built it from nothing and watched it learn your taste live. Here's everything the machine is actually handed. No descriptions, no genres, no summaries, just this, a grid. Rows are people, columns are movies. And every filled-in cell is a rating a real human being actually left. But look how little it really knows. So here's a question I want you to sit with. Take one person, one movie they have never rated, this blank right here, and fill it in, using nothing but other people's numbers. No genres, no descriptions, nobody's opinion. Can that even be done? That impossible looking blank? That's exactly where we start. We know nothing yet, not who this person is, not what this movie is. So what's our single best guess for the rating? The global average. Call it this, about 3.5 stars. Is it dumb? Completely. But it's honest. With zero information, you guess the middle. This is the floor, and every layer we build after this has to learn its place by beating it. But people aren't average, are they? Some rate everything generously, some are stingy, and from them, a 3 means they loved it. That's not taste, that's a personal offset. So we add a per user shift. This, how far above or below the average this particular person tends to sit. Same story with the films. Some are loved by almost everyone, some are almost universally panned. That's the movie's own gravity. So add a per movie shift, this, and honestly, this alone already gets you surprisingly far. But it has one fatal blind spot. It hands everyone the same ranking, just nudged up or down. It can't let you and me disagree about the same film. It simply can't disagree. So here's a fix. Give every user a short vector, this. Give every movie one of the same shape, this. Just 2 numbers each, small enough that we can actually draw them, 2 arrows from the origin. The interaction term is their dot product, and that dot product is hiding a geometric meaning. Point the same way, big positive, the model bets you will love it. Perpendicular, 0, neither for you nor against you. Point opposite, big negative, it bets you will walk away. So taste was never a score. It was never a genre. Taste is a direction actually, and your rating is simply how closely 2 directions line up. Now, staring at this little 2D picture is tempting to name the axes gritty versus lighthearted, spectacle versus quiet drama. But nobody handed the machine those words. It has to invent this direction on its own, out of nothing but the grid. So what do they actually mean? The answer surprised me more than I expected to admit, but that's a story for later in the video. Right now, every number in every vector is pure random noise. So the predictions are garbage. And that's fine, because garbage we can measure. For every rating we actually have, compare the guess to the truth. That gap, that's the error. Add up the squared errors across every rating we know. Squared, so overshooting and undershooting both count, and the big misses hurt the most. Then bolt on a small penalty that keeps the vectors from growing wild. Hold on to that penalty term, it quietly becomes the hero. Picture that loss as a landscape stretched over millions of tiny knobs, and we are hunting for the lowest point in the whole valley. We can't see the terrain, but wherever we are standing, we can feel which way is downhill. That feeling has a name, the gradient. So take one small step down it, measure, step again, feel the slope, step down, repeat. Work out the downhill direction for a single taste vector, and what falls out is startlingly clean. Nudge your taste vector towards the movie's vector by an amount proportional to how wrong you just were. Then gently tug it back towards 0 so it can never run away. Error times the other one's direction minus a leash. That right there is learning. Every training you have ever heard of is some version of this one line looped. Start from noise, the error drops, the predictions sharpen. Loop that a few thousand times and vectors that began as pure static suddenly mean something and nobody designed them. They feel out of nothing, but the pressure is to be less wrong. But less wrong on the ratings we already have, that little phrase is hiding a trap. So before training even begins, we hide a chunk of the rating. The model never lays eyes on them. Then after every pass, we watch two numbers, the error on what it trained on and the error on the ratings we hid. Only the second one is real. That's the can it actually predict number. Everything else is just flattery. Early on, both curves fall together. Good, it's learning something real. Then, somewhere around epoch 22 to 25 on the real run, they split. Training error keeps sliding happily downward, but the held out error bottoms out and starts climbing back up. That bottom right there is the true peak of the model. Every single step after it makes the training look better and the model quietly worse. But now the model has enough freedom to fit the noise. One person's odd late night 5-star, as if it were a real pattern. It has stopped learning taste. It's memorizing the answer key. More training is not more learning. That curve bending upward, that's the machine cramming instead of understanding. Remember that penalty from Act 3? This is the exact moment it was built for. It caps how confident the vector are allowed to get, and it drags that turning point later and shallower. The whole difference between a model that generalizes and one that just memorizes. So regularization isn't some footnote at the bottom of the page, is the entire reason this thing works on movies it has never seen. So we don't keep the model from the end of training. We keep the one from the bottom of that held out curve, epoch 25, and we throw everything after it away. Because the best model isn't the hardest working one, it is the honest one, but we still haven't dared to look inside it. So let's finally open the latent space, flatten it down to 2D, and go hunting for islands. An action cluster over here, a romance corner, a little horror pocket, and I'll show you the truth, not a flattering version. The islands aren't there. The genres refuse to separate. Your first reaction, honestly, my first reaction, is the simple one. It failed. But it didn't actually fail. The axes were never meaningful to begin with. Watch. Take any rotation R and spin the entire space. Swap every P for RP and every Q for RQ. Not one prediction changes because the dot product doesn't care how you rotate it. So the axes carry no fixed meaning at all. What does axis 1 mean? Is a question the math politely refuses to answer. Only the relative geometry survives. Which points sits near which? So forget the labels. Just ask a simpler question. Who's sitting near whom? Measured by the angle between their vectors. Take Toy Story. Pull its nearest neighbors by cosine similarity and insist on at least 100 ratings so a fluke can't sneak in. And out come Aladdin, E.T., Dumbo, Home Alone. Nobody ever told it these were family films. It grouped them for one reason. The same people loved them. It didn't learn genre, it learned taste. Now, drop that 100 rating floor and obscure films with 3 ratings apiece come strolling in as neighbors. Noise wearing a costume. Raise the floor back up and they quietly vanish. The honest signal always needs enough data before you're allowed to trust it. We went hunting for tidy little genre islands and stumbled onto something far better. A machine that quietly organized thousands of films by human affection alone. In a space whose axes mean nothing and where the only thing that's real is closeness. It didn't learn our categories, it learned our tastes. And that is exactly what lets it finally fill your empty cell. Now it's your turn. You're a brand new row in the grid. Rate about 40 films right here on camera. The machine has never seen you before in its life. You're just 40 little numbers floating in an ocean of 9,724 blanks. And here's the beautiful part, we don't retrain the whole thing, we just solve for your taste vector alone. Holding every movie vector frozen in place, a single reach solve. One equation, one unknown vector, closed form. No loop, no epochs, linear algebra just hands you your direction in one clean shot. And notice this showing up a third time, same leash, still quietly doing his job. But before I show you a single recommendation, we have to prove this isn't cheating. So hide 5 of your own ratings, fold in on everything that's left, then predict those 5 completely cold. Films the model never saw you rate, and you land within about half a star of the truth. That number right there is the receipt. Now the recommendations. We score every film you haven't seen, sort the whole list, and I read the top of it out loud. And that empty cell from Act 1, the one we swore was impossible to fill, is filled with your number and is right. It never once asked your age, your gender, your country, not one word about what you actually like. It only watched what you rated, 40 numbers, and found your direction inside a space it built from nothing but other people's numbers. Then it predicted films it had never seen you touch, and it was right. That is the math that decides what you watch next. Not magic, not some profile quietly sold off to advertisers. Just this. Taste is a direction, and it found yours.